Welcome back, guys, to our DSA challenge series. In this particular phase of our series, we are looking at the questions which are based on priority queues. So let us see our today's question. Our today's question is task scheduler. In this question, we are given an array of CPU tasks, and each task is represented by the letters A to Z. And we are also given a cooling time, N. In each cycle or interval allows us the completion of one task. Task can be completed in any order, but there is a constraint. Identical tasks must be separated by at least n intervals due to cooling time. Now we need to return the minimum number of intervals which are required to complete all the tasks. So we will first of all go through the example number one. And in this example number one, we are given the task as AAABBB. And n is provided to us as 2. So what we need to do is, we are provided the letters A to Z as well as the cooling time N. The main condition of the question is there is a constraint that tasks can be completed in any order, but identical tasks must be separated by at least n intervals, and n is provided to us in the question. So the tasks are A, B, B, B. So there are only two individual tasks, A and B. So, and n is given to us as 2. So what will be the order? First of all, we will do A in one cycle. In second cycle, we will do B. Now in third cycle, we cannot do any task, because if we want to do the task A, we need at least two intervals. After A, only one interval is completed, B. So the next will be idle. We cannot do anything in this case. Then we will perform A. Then we will perform B. We are able to perform B because two cycles are already over. Two intervals are already over. One interval is this one idle and one is A. So now we can easily perform B. Then again, we want an idle interval, because for any two identical tasks, we need at least two intervals. Then we will perform A and then we will perform B. In this way, the output will be 8. That is, we require a minimum number of 8 intervals to complete all of these tasks. I hope the question is clear. Let us understand this question with the help of example number 2 as well. We are given the task as A, C, A, B, D, B. So there are 4 separate tasks. A, B, C, and D. The cooling time is 1. It means one individual task can be completed by at least n intervals. So n is equals to 1. So first of all, we will do B, A, then B, then C, then D. Then we can again do A because 3 intervals are already over and we need only one interval. So we will do A and then B. So in 6 intervals only, we are able to complete all the tasks. So I hope the question is clear, that the main condition here is only this thing: identical tasks must be separated by at least n intervals due to cooling time. So the question is clear. Now let us look at its code. What is going to be our approach? First of all, we have defined one priority queue PQ, and priority queue is the max heap. The frequency of the task which occurs the most will be at the top, and which occurs the least will be at the bottom. So this is the condition in priority queue. In PQ, we have defined a max heap. Then we have made a vector MP 26, 0. We have 26 alphabets. So what will happen? We have defined a vector of size 26, and initially we have assigned all of them as value 0. Then we have iterated through our vector task, which is provided to us in the question. And if A task is there, B task is there, then at that particular index, we are incrementing the value. So this vector will help us to count the number of times a task needs to be done. So MP I minus A plus plus I minus A will help us to assign character A as 0th index, character B as 1 index, character C as 2 index. This will help us to do that particular thing. So in this way, we will be able to count the number of times a task that needs to be done. Now, after iterating through the entire vector, we will have the frequency of each and every task with us. After that, what we are doing is, we are iterating through this vector in I equals to 0, I less than 26, which we have made MP vector. If MP at the index of I implies that that particular task is there in our MP. If that particular task is there, if that particular letter is there, then that particular index will have the value greater than 0, right? So if that particular value is greater than 0, then this condition will be true. And then we will push that particular frequency in our priority queue, that is PQ dot push MP at the index of 5. I hope it is clear. Now in our priority queue, we have the frequency of each and every task with us assigned. And then we have declared a variable time, which we will return at the end of our code. We need the total number, minimum number of intervals that we are going to store in this variable time, which is going to store the total time taken. Then we have defined while not equal to PQ dot empty. We have defined one vector loop. In this, we have maintained one vector remain. What is the use of this vector? We will come to know in the later part. And we have defined one cycle. What do this cycle mean? In the question, there is a constraint that individual task must be separated by n intervals. This is that schooling time. So in one cycle, we can perform how many tasks? N plus 1, right? N plus 1 is the CPU cycle length. If n is the cooldown period, then after a task A, there will be n more tasks. Hence, n plus 1 will be the length of this particular cycle. Now, while cycle and not equal to PQ dot empty. If both these conditions are true, our priority queue is also not empty, as well as the value of cycle is also not 0. Then this loop will keep on going. In maximum frequency equals to PQ dot top. In a priority queue, we have stored the frequency of each and every task. So PQ dot top will return us the frequency of that particular task. The task at the top should be first assigned the CPU as it has the highest frequency. Then we'll pop it out. If frequency is greater than 1, suppose A is occurring 3 times. So its frequency is stored as 3. So if its frequency is greater than 1, then what we need to do is, we need to again push it into our queue, right? But we cannot push it inside this loop. If we push it inside this loop only, then what will happen is, if the cycle, we will not be able to count the idle time. So that is why we have maintained this vector remain. So we will push that particular thing in our remain. And once this loops get completed, we will iterate through this remain vector and push it in our priority queue. So if max frequency is greater than 1, it means we need it in the priority queue later. So we will first of all push it in the remain vector. Remain.pushback max frequency -1. Why -1? Because one time we have already done this particular task here. Now its frequency will reduce by 1. Plus time, because we are doing one task, so time will increase by 1, as well as cycle will decrease by 1. So this loop will keep on going until and unless both of these conditions remains true. After that, we are going to iterate through our remain vector and we are going to push it in a priority queue, which I told you just now. If priority queue is empty, then we can easily break the loop, because if priority queue is empty, this condition will become false and we can break the loop. It means we have done all the tasks. Now we don't want. So we will break the loop. If it is not empty, then we need to add the idle time. Idle time is stored in our cycle. So what we will do, time is equals to time plus cycle. This will help us to count the idle time, and after that we will return time. The question was pretty difficult, I can say, but if you will see the video once more, it will be much more clear. So let us first of all do this trial. What we are trying to do. See, in example number 1, what we are trying to do is A, B, B, B. This is there. So what we will do first of all, we are counting the frequency of each and every task. So at index 0, we are assigning at A. So that vector will be at 0th index, its value will be 3. At 1 index, its value is again be 3. Because A is also occurring 3 times, B is also occurring 3 times. So the very first step is this thing. After that, we will push it in a priority queue. So our priority queue will have 2 elements, 3 and 3, because both of its frequency is 3. After that, we are applying a loop. See, this is the only thing which we are doing. First of all, in the vector MP, we have stored its frequency. After that, we have pushed in our priority queue. We have initialized time with 0. After that, we have while not equal to PQ dot empty, in cycle equals to n plus 1. In this case, what is the value of n? The value of n is 2. So cycle value will become 3. While cycle is not equal to 0 and PQ is not empty. PQ has 2 elements, so it is not empty, as well as cycle value is also greater than 0. Cycle value is 3. Max frequency equals to PQ dot top. 3 will be stored in max frequency. Then we will pop. If max frequency is greater than 1, yes, 3 is greater than 1. So what we will do, we will push now 2. We can push 2, right? One time A has already done. So how many times we need to do it more? 2 times. So we will put max frequency -1. We will increment the value of time value will become 1. We will decrement the value of cycle value will become 2. In this way, one more time this loop will execute. Time value will become 2, cycle value will become 1. After that, our queue will become empty because we have taken out both of them. 3, 3 was there. If we have popped both the elements, so our queue will become now empty. So cycle value is still 1, but this loop will not be able to execute because this condition becomes false. We will push the remaining elements in our PQ. Now an our queue will contain 2 and 2. 2 times A needs to be done, 2 times B needs to be done. PQ is empty. No, this condition is false. So our loop will not be get break. This is the main thing. Time equal to time plus cycle. Time value was 2, cycle value was 1. So this will help us to count the idle time. Cycle value was 1. So now time value will become 3. So this idle time will be stored. So this idle time A, B, and then idle will get stored over here. So the question is very much clear now. I hope you all would have understood this question. If yes, don't forget to subscribe to our channel and share it with your friends. Thank you.